Hello to viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about press and die manufacturing. So let's dive deep into it. Now, why do we need this press and die? Well, simple because metal parts are used in most things in this world. You might think plastic is used, but trust me, without metal, there is no world, flat out. And the ability to mold raw metal to shape that you want or desire defines what you can do. Basically, flat out. Your nation's ability to do things directly correlates to how effectively can you mold metal and everything, basically car, plane, washing machine, engines, everything. Even if you have something like engine which could have casted part, it would have sort of a lot of support structure which would be pressed metal. So that creates a scenario where anything that is substantial generally has it. Oh, by the way, it also includes electrical connectors. So even your Silicon Valley requires this. They are always assuming that this is available on the back end, so to say. So national prosperity depends on the ability to work on metal efficiently and quickly, meaning railway wheels. This is one of the critical backbone technology. We do not think about it because it's always there, but it takes time, it takes effort, it requires a lot of deliberate what you call effort. Again, a nation has to build a whole supply chain in order to sustain those things. And again, your crank rods and all that, everything. So if you can work on sheet metal without a issue, you're gonna be thriving. If you do not have press and die industry, you're gonna be stuck. So how do you power something that can do this thing, basically work on metal? Well, forming metal takes a lot of energy. Like I'm getting the first-hand example simply because this is my fume extractor Mark III variant, basically sheet metal one. This is stainless steel, almost like 0.9 mm or something, like and again, bending it by hand is like brutal. It's like none of the bends are tight, like it requires a lot of energy. So, and be mindful, this is like a thin metal. Some of these machines can easily work with something that is even thicker. So you need a lot of power. On top of that, it also has to be controlled and precise, because if you are just brute forcing it, there's a very good chance you're going to destroy the metal rather than contort it to your wishes. So control has to be there and precision has to be there. It's not raw brute force. It's like precision with it. So how do we get this sort of energy? Well, electrically, it's very difficult. So we started with flywheel. Basically, you have a giant flywheel and have a piston system connected to it. So basically, the rotation is converted into stomp motion. It's basically a piston, nothing more than that. And basically, your motor dumps the energy before the stomp, and bam, it dumps the energy. So it works. It's efficient, it works, and it has been used for like almost a century at this point in time. And if you are dealing with a low power, as in like 100 or hundreds of tons, you're generally going to get a flywheel system. Although in recent times, a new technology has entered, that is servo motor. The idea is instead of having flywheel, you will directly have the motor. Now, wouldn't that consume more energy? Yes and no. It will consume more energy, but it will also give you more control. And control is necessary, especially if you want to do some sort of contorted event where you're doing too much to the metal. Metal requires a bit of time to flow. Like if you just force it, it will crack flat out, it will tear, the metal will tear apart, no use. So you have to give it some time. But how would you do that on a spinning system? A spinning system, the crank rod is locked, you can't do anything about it. Like, and again, you can't slow it down, because if you slow it down, it loses the inertia. Without inertia, it won't do the punching. So in basically flywheel, there is a kind of limit. It's like if you have finicky operations, it becomes too tedious to deal with. You may require way too many intermediate steps in order to deal with this. So servo motors are also becoming a new thing. But again, let that be very clear. If you do not have servo press system, does not mean end of the world. It just means you have to work a bit more diligently on your die system. So servos are a thing, flywheels are a thing, but again, these things are generally few ton to 100 tons. But when you are talking about some big puppies like this sort of thing, basically when you are dealing with battleship parts or like tank parts, something solid, you need heavy puppy. At that point in time, only hydraulic has that sort of power. And again, these things can go bonkers, as in they start with 1,000 ton, 2,000 ton, 3,000 ton. So these things are robust, and they are what we call nation building equipments. You should really look into how badly USA and USSR were competing in order to make a press that was the world's strongest. Like they were going bonkers somewhere. And again, it is necessary. There are certain things that this sort of tonnages, this sort of PSI allows you to do on metal that other things simply won't be cost effective. Can it be done? Of course. It just won't be cost effective. Meaning, do you want to do this and do that many steps, or just like brute force a railway wheel in one go and then just final shape it? Bam, go. So that's why. And again, this sort of hydraulic also comes with finesse. It allows you to work on thin metal on a large surface, aka car panels. So whenever you're talking about those sort of large surface area where you have to finesse the whole metal, hydraulics is really desirable for. And you can see like hydraulics like ease into it. It can almost replicate what servo can do. Actually, that's the original one. Servo one is the new one. So servo in same sort of form factor as flywheel replicates what hydraulic can do. But again, hydraulics are generally used when you are talking about some heavy tonnage, 500 plus or something like that. Can flywheels do that? Yes and no, because the flywheel will become huge. It's just a physics, engineering, economics problem. You can do it, it's just why? So that's the power source. You take electrical energy, you convert it into rotation, either via servos and even in servos, they don't directly do the driving. They have a lot of linkages to amplify the power. In flywheel, you have inertia doing that. So flywheels are generally preferred in almost all scenario. Hydraulic, when you have to use it. Servo is like, it is a new technology, especially desirable for companies that change too much. Meaning they have a press and they're changing the dies like, oh, we are providing parts for this. Oh, now we are providing part for that. If they love those things. But if you're like, okay, we only do one thing for millions of years, then go with flywheel. So that's the power source aspect of it. Now the die part. I have no idea why it's called die, but it's die. So press is the power plant. It provides the oomph to do things. Die is the one that is actually doing the work. Now, die can be changed for different tasks. For example, the press, a company can just invest into the presses. Like, I bought the press, the end. The die will keep changing. So right now, this guy is creating a bracket. Sometimes like, hey, you can design an electrical contact. I was like, okay, you can design stamp out forks. You can do this and that. Everything can be done just by swapping out the die. The die is independent of the press. Of course, it has to be designed to work with each other. Meaning, do you have, like, if you want to eject parts, like there are stamps, what happens to that material that removed, where does it go? So press generally is designed in such a way that it has places for those metal to fall off. If you do not, or if you're punching out to two big parts that cannot fall through, of course there are some constraint, but dies are generally far more flexible, far more consumable item than press. But dies are designed to be, because it's focusing all that energy, it has to be resistance against deformation, meaning the hardest tool steel would be utilized, or sometimes carbide would be utilized. It has to be hard beyond belief. Like, it's the one that is going through all the deformation, so it has to be resistant to it. Very hard, meaning the whole structure can be made out of mild steel. It's not that important. But where you're actually doing the actual that requires a very, very hard material. If you do not use that, of course, it's not necessary you have to do that all the time, because if you're like, hey, I'm only gonna or let's say this is first batch, I'm only gonna produce 1,000 of this. You can use mild steel, but generally people prefer hard stuff, so to say. And basically, it's a wear component. Dies is classified as a consumable. You do not design in a plant was like, okay, I made the die, the end. No, die is a consumable. Depending on the design, depending on the stress loading, it could be like, hey, check it after every 1,000 hour, 10,000 hour, just throw it away. So you have to be mindful of that. And progressive die has the benefit of doing almost like a film roll development. If you have seen old film roll, it has like a sprocket wheel. Same thing happens here. You have stakes that's going, first stick is punching the hole, second, then you and then you can do step by step, and that step by step is necessary, because again, can you force metal into 90-degree bend one shot? Of course. Should you do that? Depending on the alloy, some alloys can handle it, other alloys will fracture. So you made like, okay, let's force it to 45-degree in one stamp, second stamp another 45-degree, so you do not just go via. And yeah, that's why it has so many steps. And sometimes you won't be limited by basically the holes. Let's just say you need holes, but the press and die has a limitation. Basically, the holes cannot be too close to apart. But what if your material has that? You will have stamps spread apart. So it can stamp without degrading, and your metal will get that high density holes. So that's a very big, what you call, challenge that you have to think it through. It's like, can the die and press material support it, long last it? So it has to matter. And progressive dies works non-stop, meaning once you have the roll of material, and it's not necessary you're only going to get one part. Depending on the design, depending on the requirements, you could have like, okay, it's a sheet metal and it's working inside the envelope. You can just like print out as many parts as fits. And like this is a simple example, like how do you think your car fuse holder works? This is how it's done. The copper strip comes in and they press form it, tick, 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 and they make it into a actual plug holder. This goes to your PCB vendor, and PCB vendor makes that a breakout board that is on your car. That's why I said electronics will not work if you do not have this sort of machine. And yes, this sort of machine do not have like hundreds and thousands of ton. They are designed to be faster. They are like brrr. So they are few tons only, but they focus on very high RPM. Like they can just chew through material without any issue. Every contactor, keyboard switches, springs, everything goes through something like this. So if your nation does not have this technology, you'll be like, okay, I'm going to design this thing, and all it will be like, okay, send the file to China. So you can have press. This press is a surprisingly dumb device. Again, we figured it out surprisingly earlier, you know. So you can make it in your house if you want to. It's just that die is the part that is the to die for, so to say. Now let's understand the cost matrix of this. Press is a long-term investment. Any company investing in a press, and if they're not getting cheaped out on a material, they're gonna be good. They're gonna be like sorted. Like you buy it and you forget about it. It's like a one-time investment. As long as you keep maintaining it, it will last long time, like long time. And only things you generally have to worry about is tonnage and working, so to say. They are the core vectors, like 100 ton, 200 ton, 500 ton, 3000 ton. So those sort of things, the tonnage and the working area. Now, die is, on the other hand, it's a consumable part, meaning you can be like an outsourcing firm where it's like, hey, people come to me for making electrical contact. I have a press and I design the die, or they bring their own die and they will only give you, it's like, hey, can you press something that requires 75 ton? You're like, bro, we got this. We have 100 ton. Cool. Because again, you do always want to have some margin. You never want to, oh, this is a 300 ton press, push it to 300 ton. You do not want to do that. So die is the work of art, and only few people on the whole goddamn planet can know how to do it. Because here's the deal, if you just do it, right? You go to China, you give your CAD file, ta-da, they're gonna give you a very precisely EDM machined part or something equivalent of that. Cool, awesome, but here's the deal, it's not gonna last. Because again, there is no wear component. It's like everything is fine and everything wears off, and what after that? The end. But if you're in Germany, they're like, we're gonna design this. This is gonna have screw components. This is gonna be like, of course, it creates a hell of a hassle because now you have to align all the component. But if you do through that, it allows you to like, okay, use it for X amount of time and then replace the components. Replace the components, those are the wear item, not throw the whole goddamn thing. And again, over time, especially if it's a high volume product, this sort of thing saves money. So flat out, designing something that works is super easy. And again, you may want to use that one monolithic die if it's like, okay, I'm only gonna produce like, let's say a few thousand pieces. But if it's like thousands of pieces, if you have way too many zeros, yeah, you do not want to approach that way. So flat out, it's half art, half science. You can simulate the hell out of it, but trust me, it's one of those technologies that like on paper it works. Again, I learned it the hard way. Like metal on my Fusion 360 CAD file, everything is fine, everything is tight, the freaking screws are like just working. I'm like, no. So it's one of those things that you learn after doing it. So it is a bit of work of art, and that's the money maker. Let the bigger people will happily show you, oh, this is our press. The moment you ask them to show you the die, it's like, yeah, no. So dies are like very closely guarded. Of course, depending on the product. If you are making a $1 wrench, nobody cares. Like, you know, those sort of wrench, nobody cares. It was just, if it's a dumb, simple thing, nobody cares. But if it's a part, a metal part, they're like, yeah, we can't really show you how the die works. The press, this is the press. Yeah, but die is the money-making part, and it is very confidential. Be mindful, some dies are so advanced nowadays that you can have staking operations also, meaning you can have like, I have a sheet metal part, cool, awesome. But I can embed a bearing into it, meaning you will have more action done in the press rather than after you get the sheet metal, then you have a human individual pressing other things into it. That's not necessary anymore. But it does require setup. Setup time becomes higher, but you have, okay, full part done. So cost is a very, nuanced thing. Most of the time you are paying for the basically tooling, and some amount of money goes, like very small amount of money goes into paying off for the press, but most of the money that you are spending is on the die. So what can we expect in the future? Well, this is the most hidden tech tree ever, flat out. Like, again, most people are like, okay, I want silicon technology. Like, do you have press? Oh, that's not needed. No, it is needed. How the heck you gonna make the electronic connector? And I mean inside it, everything requires it. So everything uses it. Let that be very clear. It's like If electricity uses it, every switch, contactor, plug, socket, everything uses this. And USA learned it the hard way, that they had press. Like you go to USA, there are a lot of companies that make like solid, robust, American-made press. They're like, bro, we got this. Cool. There are only few die makers, and that was the biggest issue that Justin faced when he was making that scrape thing item, so to say. Oh, grill cleaner, sorry. Yeah, and that's the another paradox, because companies are like, okay, we're gonna invest in the press. What about die, sir? It's too tedious, requires too much payment to the skilled workers. Just outsource it to China. China gets the CAD file. China now has your CAD file, meaning the die is Chinese now. What does that mean? That simply means if you sell your item, right? Like you send them to the die, you made it, you made a product, you are selling a lot of it, they'll clone it. Control C, Control V. You gave them the CAD file. Everything else is a mechanical thing. CAD file that you finally came up with, like, this is the final design, that's the proprietary part. They have it. And again, can it be replicated? Of course, but why would you put that much effort? But if you have the raw CAD file, Control C, Control V, copy, paste, clone, and they will reduce basically quality, so you can make it even cheaper and then flood the market. And most people won't be able to tell the differences, like, okay, this is a hose and this has a freaking screw. Dustin did an amazing video breakdown of that, but again, I've seen that many times. It's like, this device and this Chinese clone is way too goddamn similar. It looks like they are made out of the same mold. Yes, because many times the same CAD file has been created. Because again, many times the press is in America, so die is imported into America. So they think we have the die. It's like, no, you don't. You gave them the CAD file. They have the die. So it is very serious, what we classify as core national security and stability. Meaning if your nation can do this part properly, reliable, and I mean the full supply chain, not just like, oh, we have a lot of plastic industry, we are doing a lot of injection molding. No, are you making the goddamn die? As in like mold itself. If it's like, okay, the mold is going away, it's like, no. Who is making the mold? Injection, you can make it. You can make it in your house. It's not that difficult. Press also is the same thing. It's just bigger metal, but it can be done. It's the mold, the die part that goes into it. That's the tedious part. Same in injection molding. You will see that like a lot of companies put so much effort, oh, I'm going to make this. And the moment it becomes successful, Chinese clone floods it. How the heck that happened? Die was Chinese from day one. So, although like there is one good room, like if you are in a small scale, not too big, not too huge, basically, can I like send this sort of like sheet metal and it's like China can make it? Of course they can make it. Would they compete directly? Unless it becomes a big hit, they will not try it. So that's a wiggle room you have. But again, I'm not using press and die because again, my volume expectation is normal. So I'm using laser cut. Although I have to figure out how to bend stainless steel of this grade. It takes too much effort. If you know how to do manual, this sort of thing on large piece, do share some videos and sources that could help me a lot. So let them be very clear. This is a technology that people ignored, and that's how America became dependent on goddamn China. So this was my presentation on basically press and die industry. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.